Hello everyone. In today's competitive business environment, companies they invest heavily in advertising to increase product awareness and boost sales. However, understanding which advertising channel contributes most effectively to sales growth is essential for efficient budget allocation. Businesses need data driven insights to determine whether spending on TV, radio, or newspaper advertising generates better returns. This project focuses on building a multiple linear regression model to predict sales revenue based on advertising expenditure across different media channels. The dataset used in this study is the widely known advertising dataset, which contains information on TV, radio, and newspaper advertising budgets along with corresponding sales figures. The primary objective of this project is to analyze the relationship between advertising spend and sales performance, identify the most influential advertising channels, and develop a predictive model that helps in business decision making. By applying regression analysis, exploratory data analysis, feature selection, and model evaluation techniques, this project demonstrates how statistical modeling can be used to support marketing strategy and optimize advertising investments. This project not only provides practical exposure to regression modeling but also highlights how machine learning techniques can be applied to solve real world marketing problems. So we start with the first thing, that is, we first of all imported the required libraries: pandas, numpy, seaborn, scipy, matplot, etc. We then understood the data, used the advertising dataset. Variables here are TV, radio, newspaper, sales, etc. Sales revenue target, newspaper ad spend. I checked the data set size, data types, missing values. There were none. This ensured the data was clean and usable. Then we explored the data, tried to see the data before modeling. What I looked for was scatter plots between each ad medium and sales, correlation matrix, that is heat map. What I found: TV advertising has a strong effect on sales. Radio advertising has a moderate effect. Newspaper advertising has a very weak effect. This step helped me understand which variables actually matter. Then I created a regression equation like sales equals to B0 plus B1 TV plus B2 radio plus B3 newspaper. What I analyzed is that coefficients, how much sales change when ad spend increases. Intercept base sales when ad spend is 0. TV had the largest coefficient. Radio also contributed positively. Newspaper contribution was negligible. The next step is feature step. Since newspaper was not helping much, so what we did is that we built different models with different combinations: TV plus radio plus newspaper, TV plus radio only. And then we compared models using R square. Result: removing newspaper did not reduce model accuracy. Simpler model TV plus radio was better and more efficient. This proves not all variables are always useful. Train or test split. To check if the model works on new data, we have split data into training test 80% and testing set 20%. I trained the model on training data, then tested it on unseen data. For model evaluation, I used two metrics: RMSE, how far predictions are from actual sales, and R square score, how well the model explains sales variation. There is low RMSE, high R square, which shows that the model performs well. Then model diagnostics. I checked residuals, actual predicted values, use residual plots to see the errors are randomly scattered, no clear pattern. This confirms that regression assumptions are satisfied and the model is reliable. Interaction or synergy analysis. Here I checked what if TV and radio ads together create extra impact. So I created a new feature, TV into radio. So I created a new feature. This trained a new model including this interaction term. R square, it increased slightly, showed combined advertising works better than isolated spending. Very strong business insight. Moving on to the conclusion. Model's performance, that is R square equals to 0.897. The model fits very well overall with an R square value of 0.897. That is 90% of the variation in sales is explained by TV, radio and newspaper advertising together. This is a very strong model fit. In simple words, advertising spending explains most of the sales changes. TV advertising has a statistically significant and positive effect on sales, P less than 0.001. When TV spending increases, sales increase. P-value less than 0.001 means this result is very statistically significant. There is extreme strong evidence that TV ads impact sales. TV is the strongest predictor. Radio advertising effect. It says radio ads also help sales grow. Radio has a positive impact. It is statistically significant. Spending more on radio increases sales. Radio is also important. Newspaper ads don't have a statistically significant effect. P equals to 0.860 is very high. This means the effect of newspaper ads is not statistically significant. We cannot confidently say newspaper spending increases sales. Newspaper advertising is not useful in this data set. The overall model is statistically significant with a very high F statistic, that is 570.3. F test checks whether the whole model is meaningful. Since F statistic is very high and P value is very small, this model is statistically valid. At least one variable significantly affects sales. So according to me, the companies should spend more on TV and radio. Reduce or reconsider spending on newspaper. Optimize marketing budget allocation. This converts statistical results into real business decision making. That's all. Thank you very much.